Hello everyone. You had asked me how to find the formula of centripetal acceleration. The formula of centripetal acceleration A is v square by r. Here it is. And I'm going to derive this formula for you. So imagine this is a big circle of radius r and there is a yellow mass m. This is the mass of the object, which is m. This mass is moving anti-clockwise with uniform velocity v. So the magnitude of velocity is magnitude of velocity is v, right? As there is change in direction at different positions, there will be change in velocity. So if the velocity with direction is v1 at this point, then at this point it will be v2. So we can say if we take only magnitude, then v1 is equal to v2 is equal to v in magnitude. Let's see the motion of the yellow sphere. So this is the sphere which is moving anti-clockwise. Now it will come to rest. Imagine these are the two positions of the ball between the time interval delta t. So this is position A and this is position B. Between the position A and B, the radius of this circle subtends an angle, let's say delta theta, at the center of the circle. And the center of the circle, let's say it's represented by O. The green arrow, which is tangent to the circle here, this represents velocity at A, and because I'm taking magnitude and direction, so I will write as v1, though in magnitude it's a v. And at point B, the velocity of the yellow sphere is represented by v2, which is again in magnitude v. Now if we draw these two vectors, which are v1 and v2, then we will get a diagram something like this. So here is this green vector, which is parallel to the vector at point A, and this one is the blue vector, which is parallel to vector at point B. Now because they both are velocities at point A and B, the change in velocity is represented by a new vector, which will be something like this. So let's draw that new vector, and this is the red vector, which is representing the change in velocity delta v. So what is delta v? Delta v is v2 minus v1. And as we have seen earlier that this is angle delta theta, so this is also going to be angle delta theta. Okay, for a large circle, so imagine the radius of circle is large, so circumference will also be large. In that case, if we take small part of the circumference, that will look almost a straight line, something like this. So what we are getting here, we are getting another triangle which is A, and center of the circle is represented by OB. Triangle AOB and triangle, let's give them a name here, AB, and this one, let's say Q. So triangle A here, O and B. Triangle AOB is similar to triangle AQB. Triangle AQB. So since we know this angle is theta and this angle is theta, right? And V1 is equal to V2. Similarly, here radius R is equal to another radius R. So we can write delta theta is equal to delta V by V1 by using this triangle AQB, and similarly delta theta is equal to AB by this AB by R. Since we know V1 is equal to V2 is equal to V, so what we can write here, let me go on the next clean slide. So we can write here delta theta is equal to delta V by V is equal to AB by R. Now, if we rearrange them, we can write them as delta V is equal to AB by R into V. Dividing both sides by delta T. Delta T is the time interval between AB. You know that, right? Time interval between AB. That will give us delta V by delta T is equal to AB by R into V by delta T, right? So if I rearrange this, it will look like this. Delta V by delta T is equal to AB by delta T into V by R. Now you know AB is the arc length for the circle, right? So here we can write delta V by delta T. What it represents? It's a acceleration. So we can write here acceleration A is equal to AB by delta T. What does it represent? So AB by delta T represents velocity. So let's say that velocity into V by R. So finally we can write A is equal to V square by R, and this is the formula of centripetal acceleration. And centripetal acceleration is a vector quantity, so I'm using arrow over the letter A. Now if you multiply the centripetal acceleration with mass of the object, then you will get centripetal force, which is Fc is equal to m into A, and you know centripetal force is m, A is V square by R. So that's it related to centripetal acceleration, and very easily we found the centripetal force as well. Keep revising, and if you want to ask any doubt, let me know.